This podcast is supported by Siemens, your partner for industrial-grade AI.
Hello, everybody, and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber, and my guest today is Danny Smith from AWS. Danny, welcome to the podcast.
Hey, thank you, Robert. It's a pleasure to be here with you.
We got to know each other at Harting and had a discussion in the evening, and we are continuing that here, Danny. But before we start, please introduce yourself briefly to the listeners.
Yes, so hello, everyone listening. Danny Smith. I'm a Principal AI and ML Strategist with Amazon Web Services. I have responsibility for global automotive, industrial, and manufacturing sectors.
So, Danny, one thesis was that Europe's, perhaps even Germany's startups having a problem because too many believe that their AI model is their asset. What do you think?
Well, I think that the models may not necessarily be the moat, if you will, to use the terminology of like venture capitalists, right? But the data that the model is built on may actually be a moat. But we at Amazon Web Services have never believed that there's going to be one model to rule them all, right? We've always supported choice and flexibility for our customers. And we continue to see a variety of models being used, especially when people start to move into production. So the cost optimization aspect kicks in.
But do you see this problem with Europe's and German startups? That the AI model is their asset, or they believe it?
Possibly. So I think what I see is there's continues to be a proliferation of models and model providers out there. So where I see an interesting moat is around domain expertise, right? So I think there's opportunities for startups if they say, hey, I'm going to, include GenAI and do something like around maintenance or around quality or something like that, right? So a domain expertise. Because otherwise, I think if they're just bringing the model and models continue to proliferate, right? We keep seeing new models every day, and the open source models in particular are very interesting, right? Then what's going to differentiate these startups? And so that, I think, is a question.
Yeah, but because from my point of view, we are seeing models become a commodity, especially when we talk about the vision sector or something. Are we also seeing this in other areas, or what do you see?
Well, for generative AI specifically, I think we are seeing some model, like we're seeing like a concentration from model builders, right? So the high quality models are coming out from like 6 or 7 or 8 companies, right? And for sure. But I think we're just at the early days. And so what I think, especially within our, industrial area, is the interest in models at the edge, right? Ones that run locally, small language models, right? That are domain specific. This, I think, is an area where we're going to see a lot of innovation. How protected that innovation is, is there a moat? Remains to be seen.
What I'm currently noticing, because you mentioned GenAI, is that startups, maybe with good ideas, are now switching to this co-pilot application. They are struggling with their maybe actual plan, and now they're trying to realize LLM projects quickly to earn some money. How do you see that? I think I see a lot of them.
Well, I think there's definitely CEO level attention for generative AI right now. And so, the challenge with traditional machine learning has always been there's like a cultural gap between, like, I'll give you, like, I'll equate it to the differences between OT and IT. There's this big OT-IT divide, but like for an operations technology person on the shop floor, data science looks like, an even more dangerous, risky version of IT, right? It's black box and stuff. And so for traditional machine learning, there was always this cultural gap where we had to kind of get over the cultural gap or make sure that we had the business fully engaged. Now, GenAI brings in a whole nother dynamic, but it's being pushed from the top down. And so the adoption challenges may not be there, but we're also kind of looking at GenAI as like a magic wand that will fix all problems. And, we know that that's not true.
But do you also realize that these startups are now, everybody goes on LLMs and GenAI and wants to earn very fast a lot of money, but they actually lose their vision what they did in the past with traditional machine learning maybe?
I think there's a danger of getting distracted, right? So, Gen AI is at the top of the hype curve, right? When you know what comes next, everybody falls off the cliff. And so I think, fundamentally, it's like, are we providing a service that's differentiated, that adds value to the customers? If they're focused on that, then the technology could be Gen AI, could be other things, right? But if they're just attaching the word large language model or Gen AI or something like that, to their pitch deck just to get funding, then that may work early. But I'm thinking that they're going to get into trouble later.
You mentioned maybe when you are a domain expert when you are a domain expert, you have better chances on the market. What's your opinion? Is it maybe the future of startups is in data or in hardware, or consulting is not an option, I think?
Well, I'll get back to that question in just a second, but I do see that there's a lot of opportunity for consulting around this area because it's so new and people need guidance. But you don't create a startup to be a consulting company if you want high valuations, right? These are what I call the lifestyle, companies, or sometimes you see the academic, like the professor companies, right? If you want 10x or 100x valuation, right, you need to, productize something. And so I think the productizing still has to, add value. And so where's the separation of value? It's got to be in a domain specific. Like, so if they have a background in history and maintenance, as an example, then if they bring something new to maintenance that's built on what they know and understand before, then that could be quite valuable.
So focus on domain knowledge and focus on data.
Yeah, I think so. I mean, and when we say data, I think it's, with Gen AI again, right? It's like if these models are trained on most of the public data available on the internet, what's left? It's proprietary domain, it's trade secrets. And so if you have a treasure trove of proprietary data, you can monetize it, right? And this is not a new idea, right? There's information services that, have been doing this for years. It's now, everyone's going to scramble around, startups as well as large companies, right? They may even spin off a startup, right? And they say, hey, we've got this treasure trove of valuable data. How do we monetize it? Oh, of course, a large language model, access to it or something like that.
So you mentioned, I think, 3 or 4 sentences before that your approach at AWS is small models. What does it mean, small models?
Well, our approach isn't small models. It's giving customers choice and flexibility. But what we see our customers looking at is a variety of use cases for these models. Some of them need these large, highly performant models. But if they're going after like a knowledge store question and answer, right, which uses architecture, retrieval augmented generation, what they're finding is that they don't need the most performant, or potentially expensive model, right? They could use a much less generally performant model, but actually works quite well when you use it in a RAG architecture. And so that definitely is, and these RAG architecture use cases are probably 70 or 80% of the use cases that are floating around out there at the moment. But the small model piece is so there's a combination of that, but there's also this interest in our sector, whether it's on the industrial side or on the automotive side, that, small local models that run close to the edge, right? Whether it's in car or next to the line, because we can't assume bandwidth, up to some cloud, right? So the ability to kind of create a really small type model that does what you need it to do with a small, with a, low impact footprint, that's definitely something of interest.
And do you provide these small models?
So we provide like infrastructure and services to help you take advantage. So most of these small models, or I would say all of them, really are based on open source models. And so we have a long-standing relationship with people like Hugging Face, right? And so you can pull in an open source model from Hugging Face, use that, fine tune it, continue to train it with fine tuning with your data, and then kind of, make sure that it's the equivalent of a tightly compiled model, right? Its technology is not the same, but the idea is let's get this small, tight, low latency, small footprint for compute. So we provide the services to be able to take advantage of this, but we don't tend to provide a lot of models ourselves. We do offer some, and that's what's called our Titan models, and they have very specific uses. But what we see is like the Hugging Face relationship. I mean, I just, looked in Amazon SageMaker, which is our high-speed assembly line for building machine learning applications, is probably a good way to say that. But within SageMaker, you look at, just Hugging Face, you have like access to like 300 models, right? And then, outside of Hugging Face, there's another 400 or 500 that are floating around that you can just press a button, click on it, and deploy an endpoint. So there's a lot of flexibility. And so we provide the flexibility and the tooling and the services to have people build these themselves.
But when I now want to use a small model, how do I build now a small model? Do you build the small model for me?
Well, typically these base models are already available through open source. I mean, you certainly, and look, if you want to start from the ground up and build a foundation model, you certainly can. And we have many model providers. So as an example, people like Stability AI, built some of their models using Amazon SageMaker. We have people like Anthropic who provide the Claude models. They're building, their next generation of models leveraging AWS infrastructure, right? Our specialized chips. So you can definitely do that. We just don't see many people building things from the ground up. That's a narrow, like a smaller group of companies.
But what use cases are they currently approaching with you, your customers in automotive or in manufacturing? Are they all focused on GenAI, or is there also a place for traditional machine learning?
Well, we have over 100,000 customers across all industries building machine learning, right? Traditional machine learning. Now, for GenAI, and then specific to my area, automotive, industrial manufacturing, we see a huge number of use cases all over what we call, strategic workloads. And so the strategic workloads are things like autonomous mobility or software-defined, everything, right? Whether it's software-defined vehicle or software-defined equipment or product. Things like smart operations, right? So smart factory, smart supply chain, customer experience, right? So so we see GenAI use cases as well as traditional machine learning use cases across all of those, strategic areas. We also see increasingly that the combination of traditional machine learning or traditional AI services with generative AI, provides a better answer than just one or the other alone. And I'll give you an example of that. So, anomaly detection for things like rotating equipment, right? So got a motor running and, maybe you're monitoring for vibration and temperature. And so this is a traditional machine learning application, right? Very, very well done, right? But what's interesting, right, is you can take the feed from that, bring it into a digital twin, but then you can also lay generative AI capabilities on top of that so that one, you can ask questions of that data. So the example that I always use is if you've detected an anomaly, show me the most influential variables, right? So maybe you have 300 sensors. Show me the most influential variables that are causing an anomaly alert to be triggered, right? And then show me normal and then show me abnormal. And this helps like an engineer with root cause.
So it's a combination of both.
Exactly.
It's a combination from traditional machine learning and GenAI.
Yeah, that's exactly right. Because if you think about it, there's probably a bunch of root cause analysis documents, diagnostic plans that are behind that equipment. And so if you see the sensor behavior, and then if you can, quickly using, generative AI to ask questions of the diagnostic manuals, then you can actually get to root cause, faster than you could before.
But how difficult is it to combine both worlds?
I don't really think it's that difficult, but use case, these are specific use cases, right? And so the example I gave is very easy, but you have to have the underlying data. So here's an example, like what if we had the anomaly detection, but we didn't have a root cause analysis diagnostic manual, right? If you don't have that manual, then generative AIs
won't help you. Yeah.
Yeah, exactly. Or help you a lot less than...
Yep. Yes. So the first is I need more data than when I want to combine both worlds.
Possibly. But here's an interesting thing. When I ask people, about data, like my customers, and they say, oh, we don't have enough data. And then when we start drilling down, right, and digging deeper into the situation, they have data, but the data is just scattered. It's hard to get to. they may have a lot of correction of error reports that analyze root cause on someone's desktop in a document. But that's not something that's easily accessible for an enterprise use with GenAI immediately, right? And so one thing around generative AI is it causes you to kind of double and triple down on your data strategy. As much as machine learning is data-driven, generative AI really exposes a bad, decentralized data system.
You see many AI applications and technologies. What do you see on the horizon? What will be the next trend in the industrial sector from your point of view? So you mentioned maybe small models on the edge.
Yeah, I think you'll see proliferation of those. You'll also see domain models coming out that have specializations. But we have a challenge around the domain models.
What is a domain model? Can you please explain us in 2 sentences what is a domain model?
Yeah, so I'll give
a welding model or something.
Exactly, right? So a model tuned to a specific purpose. And you see these models in things like healthcare, right? It's like, hey, I want to do protein folding, right? And things like that. But what's interesting is if your trade secret data is the moat, it all depends on, do you have access to data? Or if you want to have, like someone asked me, could we have a manufacturing large language model tuned to manufacturing? Well, we have a bunch of standards, from different organizations around the world that we could feed into one and build one. But maybe what they really mean is, well, all of my equipment is Siemens, or all of my equipment is Rockwell, right? Or all of my, or I use FANUC robots. And
my FANUC should also use the LLM as a KUKA robot.
Yeah. So, but all of those companies, that's their intellectual property. And so if you want to build a robotic model, as an example, right, there's certainly robotic standards, but I'm not sure any of those companies are going to be willing to go in together with their competitors to provide a model that's beneficial across multiple robots, right? Because what they'll do is that, that robotic company will create their own that's specific to theirs. So I think there's great opportunity for these domain models, but I think who gets the money is going to cause a lot of limitations to what we could really do, which you don't see in places like healthcare.
So you mentioned domain models. What is also technology you see on the horizon, or an approach?
Well, so this will be really interesting. But right now, the transformers.
Oh, it's the end of the transformer?
Well, I don't know about that, right? But the transformers is not. It's very compute intensive, and so what I think we're already starting to see it with people trying to figure out how to make it more efficient. So you've got quantization and all this kind of stuff. But there are other approaches, not necessarily based on that transformers, approach.
For example?
Well, I was going to say, I hate to mention any of them in particular.
But for example, Sepp Hochreiter is working on an XLSTM approach.
Yeah, there's several of them, but it's so early. I don't know if they're any good, right? I mean, like for all of Transformers' faults, we know it works. But I think we're seeing some real sophistication. So you saw Elon Musk's company XAI release their Grok model. Now it's transformer based, but it's a mixture of experts model. So there's all kind of acceleration of innovation based on trying to get better answers, also, more efficient compute, et cetera. But I think there's going to be something else come soon. Now, the big unknown for me is, how does this work with quantum computing? Because quantum is always like the holy grail. We're trying to keep getting to quantum computing, but we never quite seem to get there in a commercial way, but we keep making more progress. And so I'm wondering if the collision of quantum computing efficiencies with some kind of architecture that's beyond maybe transformers, if that'll make it really interesting, but to be determined.
Do you have a time horizon for that?
No, but if you'd asked me 3 years ago, would we have the capabilities we had for LLMs now, I probably would have said 5 to 10 years. So we seem to be accelerating.
Okay. What is on your desktop for the next months?
Oh, for me, just meeting with customers and talking about general capabilities.
What are their pain points in the moment?
Well, I think from an executive standpoint, there's still a lot of confusion about the reality of these models, right? So there's okay, they've heard the hype. All the consulting companies are telling them, whispering in the ear, you could, this could be a, $4 trillion opportunity or whatever. And then they're like, okay, but what does that really mean? How do we roll it out? How do we scale it to the entire organization, right? If I wanted to accelerate people, right? And remember, in our industry, we've been like master black belt, Toyota production system, Lean, Six Sigma, like all of these approaches for decades, right? Improving the process. But what we haven't done is really invested in making people more efficient, right? And so GenAI to make people more efficient is really intriguing, right, to the organization. But still, if you wanted to accelerate all of the people in your organization, how would you do that at scale for a reasonable cost? And so, my conversations are pretty practical in those regards.
So, okay. Danny, we wish you all the best. Thanks for the conversation. Thanks for your thesis. Have a good day and thank you and bye-bye.
Yeah, Robert, thank you. And see you in Hannover Messe next month.
See you in Hannover Messe. Yeah, absolutely. Bye-bye.